Guess it's just us. All right. So the other day we were talking about area of a triangle and area of a parallelogram. Any questions on those formulas? So remember, for a parallelogram, the formula is area equals base times height. For a triangle, formula is area equals 1/2 base times height. Okay, so today we're just going to talk more about areas of triangles. This is more triangles. So in particular, what I want to talk about is what if you have triangles that are graphed on XY plane. So for example, what if they said, find the area of triangle ABC, and then they give you coordinates for these points, A, B, and C. What if they said A has coordinates 2, -1, B is 2, 5, and C is -3, -1. This should be pretty easy. You can just graph the triangle. Graph paper here. I think we're actually running low on graph paper back there, so we need some. You guys need a piece of graph paper? I'm going to restock over here. So if we graph this on graph paper, this is a pretty easy problem. A is 2, -1, that's here. B is 2, 5, right there. And C is -3, -1, that's here. So if you draw this triangle on graph paper, you could literally just count squares. This is a right triangle, so you could literally just count squares to get the area of it. Right? You can count squares this way, and you see this has a length of 5. You can count squares this way, and see this has a length of 6. So the area would be 1/2 base times height, which is 1/2 of 5 times 6. Half of 30 is 15 square units. That's pretty easy. Let's try another one. Sometimes it doesn't turn out to be quite so straightforward. What if it was point P has coordinates -2, 4. Point Q is at 5, -3. And point R has coordinates 7, 5. Okay, if I do the same thing and I graph this, we have -2, 4, that's this point. 5, -3 is over here. And 7, 5 right here. the problem here? How is this problem different than this problem? You can't really count the squares, exactly, right? You can't say, well, this length is whatever because I'm just counting squares. You can't say this length is whatever. Because the point is that none of the sides of the triangle are vertical or horizontal. So you can't just count squares. Okay? Now, there's options. Like one thing you could do maybe is you could use the distance formula, which sounds like an awful idea, but you could do it, right? You could calculate the length of r cubed, for example, and then figure out like perpendicularly what the distance is from P to that point. But then you'd have to figure out what the point is that would go perpendicularly to r cubed from P. It seems like it would be difficult to do, okay? Or I could use PQ as the base and then the altitude from R. But it's the same issue. I'd have to figure out where the altitude from R would actually land on PQ in order to calculate its distance. So it would be sort of a hard process. So it turns out there's a better way to do this if none of the sides of the triangle are vertical or horizontal. Okay? And here's what you do. So this is if none of the three sides are vertical or horizontal. None of the three sides are vertical or horizontal. You just enclose the triangle in a rectangle. And subtract the area you don't want. Okay, so what I mean is, draw the smallest rectangle that completely contains triangle PRQ. So in this case, I could draw a rectangle that goes this way, and then down to here, and then over. So this is the smallest rectangle that would contain the triangle that I'm looking at. And if you think about it, the area that I'm looking for is really the area of this rectangle minus the three triangles that don't belong in the area that I'm looking for, right? So if I shaded the areas that I don't want to include, I don't want to include this little triangle right here, right? I don't want to include this area right here. And I don't want to include this area right here. But each of those three triangles that I shaded have, they're right triangles. Like we could just calculate their area just by counting squares. Does that make sense? Like this area right here of that little piece is 1/2 base times height. Well, I can just count squares. The base is 1, 2, 3, 4, 5, 6, 7, 8, 9. And the height is 1. So 1/2 of 9 is 4.5. And this triangle here on the left, its area is 1/2 base times height. The base is 1, 2, 3, 4, 5, 6, 7, just counting squares. The height is 1, 2, 3, 4, 5, 6, 7, just counting squares. What's that?
Oh, no, sorry, never mind.
Yeah.
I multiplied 7 times 2 and minus 7 times 7, so it's 49.
Right, so what's half of 50?
25.
Yeah, so half of 49 would be 24.5,
Okay.
right? So this would be 24.5. You're right. And then this triangle right here, same thing. The area is 1/2 base times height. The base, counting squares, is just 2. And the height is 1, 2, 3, 4, 5, 6, 7, 8. Half of 16 is 8. So the total area that I'm looking for, so the area looking for is the area of the rectangle minus those 3 triangle areas, right? So the area of the rectangle, if I count squares, is 1, 2, 4, 5, 6, 7, 8, 9. 9 times the height, 1, 2, 3, 4, 5, 6, 7, 8. Right? That's the area of the rectangle. Minus those 3 triangles, which are 4.5, 24.5, and 8. Okay? So this first thing is the area of the rectangle. What's that?
72.
Yeah. So this is 72. And these are the areas of the unwanted triangles. Which, if I add them up, 24.5 plus 4.5 is 29. Plus 8 is 37, yeah. So 72 minus 37 would be 35. So that's the area of the triangle I was actually looking for, 35. Does that process make logical sense? It would have been a lot of work to calculate distances and then figure out the point where it goes to the altitude, to the base, and then calculate another distance and then do it that way. Because then you'd probably end up with weird numbers too. You know, when you use the distance formula, often the distances you get aren't whole numbers, right? They're like weird numbers. They're irrational or whatever. So this way we avoid all that complication and we're just calculating basic areas. Yeah, we're doing a few more basic areas, rectangle, triangle, 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 but in the end, I think it's less work, less complicated, less places for mistakes, and it works every single time, okay? Let's try another example. This works for any triangle. So like, for example, what if I have point X has coordinates -2, -5. Y is 1, 3, and Z is 4, -4. I'm just making these problems up. I'm not rigging them to work out neatly or anything like that. Okay, so if I graph this, X is -2, -5. Y is 1, 3. Z is 4, -4. So there's the triangle that I'm looking for. So same process. I'm going to enclose the triangle with a rectangle, and this will always be possible. Close this rectangle with a triangle, or triangle with a rectangle. And the area is just going to be, the area I'm looking for is just going to be the area of the rectangle, which if I just count squares, it's 1, 2, 3, 4, 5, 6. So the area equals 6 times the height, 1, 2, 3, 4, 5, 6, 7, 8, minus the areas of the triangles that I don't want. So this triangle here on the left is 1/2 base times height, which is 1/2, 1, 2, 3, times 1, 2, 3, 4, 5, 6, 7, 8. Half of 24 is 12. The area of the one right next to it on the right is 1/2 base times height, 1/2 of 3 times 1, 2, 3, 4, 5, 6, 7. Half of 21 is 10.5. And if you look at this one down here, the area is 1/2 base times height, 6 times 1, which is 3. So the area that I'm looking for is the area of the rectangle, 6 times 8, minus, parentheses definitely necessary here, right? Because you want to subtract the whole thing. 12 plus 10.5 plus 3. So this is 48 minus 12 plus 10.5, that's 22.5, plus 3 is 25.5. So 48 minus 25.5 is 22.5. Square units. Let's just do one more example. Let's do one where the triangle ends up being obtuse. Okay? So what about if we have A has coordinates 6, 7, B is 2, -3, and C is -2, -5. So if I graph this, A is 6, 7, 6, 7 is here. B is 2, -3. And C is -2, -5. So this is definitely an obtuse triangle. So this one ends up being a little bit different. If you think about the rectangle here that you can enclose this in, it's not going to contain all 3 vertices. The rectangle, the perimeter of the rectangle is not going to contain A, B, and C. But it still works. Like if I draw this rectangle, the smallest rectangle that can enclose this, on the left, that's definitely a nice clear triangle. But on the right, this is not a triangle, right? This is not triangular shaped. So what can I do to calculate that area that I don't want to include over here? Like this one's super easy. The area would be 1/2 base times height, 1/2 of 1, 2, 3, 4, 5, 6, 7, 8 times height, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is half of 96 is 48. No problem. What about this other weird shaped thing?
It's like the whole triangle from like A to, it's like A to C, like, because there's, yeah, like, there's from A to C and then down, that's the triangle. So, right? Yeah.
Well, no, okay, so if we're trying to calculate this area, right, then we want to subtract
Well, I know that you want to subtract like that part, but
that, we got it. And now
since that space there or actually, never mind that. But, never mind.
Do you have an idea?
And maybe from B, you can draw a line to the right angle.
Like down to here?
Yeah.
Oh, that's one possibility, absolutely. I'm not gonna do it that way, but definitely that would work, right? Like I could draw a line from B straight down to this corner of the rectangle.
See the height.
And yeah, then the height's 2 and the base is this. And over here, the height would be 4 and the base is this. That definitely works. And I'm not saying you shouldn't do that. That's a good idea. I was just thinking, why not just split it like into like 3 pieces? We got a rectangle, which is super easy to calculate its area, and then 2 triangles, which are super easy to calculate their area. Your way works perfectly, though. I mean, there's no problem with it at all. This area here, we'll get the same answer whichever way we do it. This is going to be 1/2 base times height, which is 1/2 of 4 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which is 20. And this one down here is 1/2 base times height, 1/2 of 4 times 2, which is 4. So the total area that we don't want to include would be 48 plus 20 plus 4 plus 8, right? We would have gotten the same thing if we had done it your way. So the area that we're looking for then is going to be the total rectangle, base times height, 1, 2, 3, 4, 5, 6, 7, 8 times the height, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, minus 48 plus 20 plus 8 plus 4. It's the same concept. We're still taking the rectangle minus all the stuff we don't want to include. So this is 96 minus, if you add up the stuff that's in parentheses here, we have 68 plus 12 is 80. So the area that we're actually looking for is 16 square units. Any questions on this process? So you definitely need some graph paper to do this assignment.
Yeah. And I'll let you complete the square on the open lines.
I don't think so. Let's check it out. Yeah, I don't think it's like a guided thing. I think it's just they're asking you the area and they don't give you like any type of way to do it. Let's see. So this is the assignment right here. Oh, they're giving you it on this part of the assignment, they're giving you the triangle or the rectangle that you want to use. But on the next part, I'm not sure, there's 2 sections of this. Level 2. Yeah, it's the same idea. But this one, they don't draw the rectangle for you. So you might be able to just sort of visualize the triangles. What's that?
You can still see them.
Yeah, I agree. So you might need scrap paper. You might need scrap paper, but it doesn't necessarily have to be graph paper. You can just kind of eyeball it and tell that this is the triangle you're subtracting. This is the second triangle you're subtracting. This is the third triangle you're subtracting. Yeah. All right. Any questions? All right. So it's Delta Math assignment, and it's just called area of a triangle on a coordinate grid.
About IXO, and that's from yesterday.
Yeah, the IXL assignment is from Tuesday. Area of a parallelogram triangles.